Hey everyone, welcome to another video where I'll be teaching math. I'm Abhinav. I've done both my bachelor's and master's in electrical engineering from IIT Kharagpur. This is an episode from the playlist Back to the School. In this particular playlist, we have discussed a couple of questions that appeared on different Olympiad exams. All these problems are very beautifully designed, and the good thing about these problems is that even a high school student can understand all of them. So, yeah, I would strongly recommend you guys going through this playlist and checking the videos out. So, the link is in the description. Do check out. In this video, we are going to discuss these two results: area of circle, which is pi r square, where r is the radius of your circle, and the circumference of the circle is given by 2 pi r. So now the question is, we all know these facts, but how many of us can prove it? Maybe if you have taken your integration classes in your +1 or +2, you might be able to solve this. But can you prove these two results without using integrals? Yeah, we are actually going to do just that in this particular video. So we don't use integrals here, but we'll try to develop a different perspective of looking at things, and eventually we'll be deriving these two results. So let us go ahead. We have a circle of fixed radius r. So the radius of this particular circle is fixed. And now let us consider regular polygons. What is a regular polygon? A regular polygon is a polygon whose all sides are equal and all internal angles are equal. So for example, this is a regular pentagon. So all these angles are equal and all the sides are of equal length. So here, just for the purpose of illustration, I have made 5 circles. All of them has the radius r. So the radius is fixed here. Now in the first circle, we are inscribing a triangle. And in the second circle, we are inscribing a square. And in the third circle, we are inscribing a regular polygon with 5 sides. And in the fourth circle, we have a hexagon, and here we have an octagon. So now let us analyze. So the task is to find out or deduce the formula for the area of the circle. Like, how do we approach it? So one thing that we can do is, so instead of finding the area of the circle, we'll try to find the area of this particular triangle. Alright. So when we do that, this blue area is what will be left out. Alright. So pi r square is the area of the circle when r is fixed, and you'll get some value for the area of your triangle, which is lesser than the actual area of the circle. So this blue area is the error in the computation. Now let us move ahead. Now we have a square. Similarly, we will find the area of this particular square when the radius r is fixed. Alright, then this blue area will be the error in the computation. But the blue area that we have in this figure is greater than the blue area that we have here. So the blue area is greater here. And similarly, when we move to the pentagon, so the blue area got reduced. So the error in the computation got reduced. We'll go to the hexagon. Here also we'll compute the area of this hexagon, and the error in the computation will be the blue area. This got further reduced. So with the increase in n, the error in the computation is getting reduced. So in other words, the area of the polygon is tending towards the area of the circle. Let us say A3 is the area of triangle, A4 is the area of square, and A5 is of pentagon, A6 is of hexagon, A8 is of octagon. So this will be the order of areas, and let us say the area of the circle is somewhere here. When you compute A9, it will be close to A, and when you compute A10, it will get closer, and when you compute A11, so this will get closer than A10. So this process continues. Now, what happens when your number of sides tends to infinite? Before answering that question, let us go through these diagrams once more. So here, this is the side of the square, and if you consider this side length and this particular side length of the pentagon, so the side length of the pentagon looks lesser than the side length of the square, and similarly side length of hexagon is less than the side length of pentagon. Similarly, the side length of octagon is less than side length of hexagon. So when your n increases, your side length decreases. Alright, and when your n increases, your area tends closer to the area of circle. This area is the area of the polygon. Alright, so what happens when your n tends to infinite? When your n tends to infinite, this particular side, it just becomes a point. The area of the polygon will almost be equal to area of circle. So this is the idea that we are going to use. So here, these diagrams may be vague to you because I'm just mentioning that things might happen like this. But let us verify if they actually do happen that way. So now here I have a figure. I ran a simulation. So the first column has the number of sides of the polygon, and the second column is the area of the polygon, and third column is the area of circle, and fourth column is the percentage in the error. Alright, here area of the circle, if you observe, it is constant all throughout. So pi, I have this is actually pi. So I have considered a circle whose radius is 1 for the sake of simplicity and calculation. Alright, so in here the radius of circle is 1. In the unit circle, we are inscribing triangles, squares, pentagons, all of those things. So when the number of sides is 3, this is the area of the polygon and this is the area of the circle. So if you compare these two, there is a 58% error in the computation. Let us go ahead. When number of sides is 4, the area become 2, area of the polygon become 2. So it got closer to the actual area of the circle. When the number of sides is 5, the area become 2.37. It still got closer to the actual area of the circle. Let us say when the number of sides is 10, so the area is 2.9 and the actual area of the circle is 3.1. So it is very close to the actual area. And what is the percentage error in the computation? It is 6%. So now let us see when the number of sides becomes 100. So the actual area is 3.14, the area of the polygon. The area of the circle is also 3.14, and the error in the computation is 0.06%. It is not even 1%. It is not even 0.5%. It is 0.06%. When the number of sides goes to 1000, so this is the area of the polygon and this is the area of the circle, and the error is 0.0006%. So these values are all in percentages. So the area of the polygon when the number of sides is 1000 is almost equal to the circle, and this is the error. This is almost 0%. Now think what happens when n goes to infinite instead of 1000. So it will actually become a circle. So this is the idea that we have. Now let us go ahead and derive the formulas. So let us say this is a circle. So this is the circle that you have. So let us say we have a regular polygon which has n sides. So we have a regular polygon which has n sides, and I have just shown 3 sides here. Okay, so let us consider this particular side. This is the center of the circle. Let us join this particular vertex and this particular vertex. Alright, then this angle will be 2 pi upon n. How is it 2 pi upon n? So there will be n sides. Alright, so there will be n such triangles formed like this, and the total angle is 2 pi. And since it is a regular polygon and there is a perfect symmetry, this angle will be total angle 2 pi divided by the number of sides, that is n. So this angle is 2 pi by n, and this is simply radius of the circle. This is also radius. Alright, now what we will do is we will first try to find out the area of this particular triangle. How do we do that? We can do this from the sine rule. So area of triangle is half a b sine of the included angle. So half r sine of 2 pi by n, which is half r square sine 2 pi by n. So in this polygon with n sides, there will be n such triangles. So the area of the polygon will be simply n times the area of each triangle. So I've just written that here. Now when this n tends to infinite, this particular area will tend to the area of the circle. So therefore area of circle will be limit n tends to infinite the area of the polygon. So let us say this 2 pi by n is t when n tends to infinite. So this will become infinite, 2 pi by infinite will be 0, so t tends to 0. So now area of the circle will be limit n tends to infinite. So here we are replacing it with t. So limit t tends to 0. This r square by 2, r square by 2. This n can be written as 2 pi by t from this particular thing. So this is 2 pi by t and sine t, since 2 pi by n is t. So here t is the variable. So pi r square comes out of the limit because those are not depending on t, and this 2 and this 2 gets cancelled, and it is simply limit t tends to 0 sine t upon t. And this is a very famous result. The value of this limit is 1. So this limit is a very famous one. This is a result, and the value of this limit is 1. So the area of the circle is pi r square. So we have proved it without using integrals. Maybe a high school student might not be able to do this sort of thing. He might not know this particular result, or he might not know this way of writing things. He might not know limits and all, but like developing thought process, like getting the thought that if we inscribe a regular polygon with n sides inside a circle, and if we keep increasing the value of n, so when that n tends to infinite, the polygon becomes a circle. So this thought is what matters. Once you get the thought, doing this math is very easy. So yeah, now let us go and find out the circumference of the circle. So whatever triangle we have seen in the previous slide, I have taken the same triangle. This is r, this is r. Let us assume the side length is x. Alright, the central angle is 2 pi upon n. Since these two sides are equal, these two angles will be equal, so I have assumed theta and theta. So sum of angles in a triangle is 180. So from that we get theta is equal to 90 minus pi upon n. So let us apply sine rule in this triangle. X upon sine 2 pi by n is equal to r upon sine theta, which is 90 minus pi by n. Sine 90 minus pi by n is cos pi by n, and this is sine 2 theta. Sine 2 theta can be written as 2 sine theta cos theta. So we have this particular thing here. Now this cos pi by n gets cancelled. So your x will be 2r times sine pi by n. So when you put n is equals to infinite here, this quantity will become 0, your x becomes 0. So this side length becomes 0, which is a point. So there will be a lot of points, and all those points forms a circle, just like what we have discussed. Alright, so now circumference will be, so this is the side length. Now the perimeter will be, since there are n sides, so n times of this will be perimeter of the polygon. Now what is the circumference of the circle? the perimeter of the polygon when n tends to infinite is the circumference of the circle. So similarly, consider pi by n is equal to t. Since n tends to infinite, t tends to 0. So 2r is independent of t. So 2r will be here, and n can be written as pi by t from here, and this is sine t. Since 2 pi r is independent of t, it comes out of the limit, and this is limit t tends to 0 sine t upon t. Again, the value of this limit is 1, so the circumference is 2 pi r. So yeah, even without using integrals, so there are very novel approaches which you can take to prove the well-known results. So, and this is the best example that fits into this category. All right, now doing all this math limits is not important, but getting the thought that a polygon becomes a circle when n tends to infinite should be the key takeaway from the video. All right, thank you very much. If you like the content that I'm making, hit that like button, share it with your friends, and subscribe for more such content. And I have made a lot of playlists. I've solved JEE advanced questions, and I've explained the concepts of integrals and limits, and now there is this back to school series. I'm adding all these links in the description below. Do check out the links, and if you have any queries, do comment out. Thank you.